Hi everybody, my name is Karsten, and in this Honeycomb how-to video, I'm going to talk a little bit about the types of spatial data that Honeycomb supports and how best to structure your data in Snowflake so that you can use it in Honeycomb. The first thing to know is that the base grain or the most specific data that Honeycomb supports is the point. And everything is built up from points. So here I have a simple Honeycomb map showing the locations of deliveries in Austin, Texas. This map is being generated from this fact order table here, and specifically this delivery latitude and delivery longitude set of columns here. So the simplest way to structure your data to bring it into Honeycomb is just to have a latitude and a longitude column within your data. And Honeycomb should be able to detect these automatically. Now, a few things to note with point data. It does need to be in two columns, and they should be latitudes and longitudes. That means if your points are in a different coordinate system, maybe they look a lot larger, you're going to need to use one of the transformation functions in Snowflake to transform them to latitude and longitude, spherical coordinates. If you want to get technical, they need to be following the WGS84 datum. So points are the easiest way to bring data into Honeycomb. And Honeycomb can support up to anywhere between 5 to 10 million points on a map, depending on the machine you're on. If you really want to show, if you have a massive amount of data and you want to show more than that, another thing that you can consider is pre-aggregating your data to H3 indexes. H3 is a hexagon-based grid system developed by Uber. And the basic idea is that you cover the Earth in these hexagons, and then you assign each hexagon to an ID. And then once you have this grid system, you can use it to bin point data into these hexagons. And the good news is that Snowflake has functions for working with these H3 indexes built in. So in this case, we're going to use this H3 lat lon to cell function. So let's assume that this fact orders table had billions of orders because the company is just so successful. And we want to show these on a map. Now, Honeycomb doesn't currently support rendering billions of points, not yet at least. So we're going to aggregate them to H3 beforehand. We can do that with this simple H3 lat lon to cell function. And then we're going to do a group by. And what this will do is calculate the total sales for each H3 index. In this case, we're using H3 index resolution 12. Now I've already created a table with this data called metrics by H3. And let me reload Honeycomb and show you how I can import data from a table that has H3 indexes automatically. So I'll click on this table and there we go. Now, rather than being on the point level, Honeycomb has read the H3 indexes directly from the Snowflake table and rendered them onto the map. So this is a great way to encode massive amounts of spatial data onto a map in a very efficient, performant way. The downside of pre-aggregating your data to H3 is that you lose some of the grain and the specificity that you would have with individual points. For example, because my data is pre-aggregated to H3 indexes here, I couldn't add a bar chart that lets me filter and slice and dice on different fields. But if you know the type of analysis or the type of map that you want to make ahead of time, using H3 can be a really great way to put tons of data onto a map very efficiently. So to sum up, Honeycomb supports point data represented as latitude and longitude columns, as well as H3 indexes. The H3 indexes can be either represented as a string in hexadecimal format or as an integer. Now, there's a whole piece of documentation here that walks into further detail about this, and it's called Analyzing Massive Amounts of Location Data with Honeycomb. And you can find that on the Honeycomb Maps documentation site. Thanks, everyone. In the next video, we're going to walk through how to filter data for a specific area.